Hello, good afternoon, welcome. My name is Spencer Gibb. I'm going to be talking about Spring Cloud and discovery systems and configuration systems. We'll do some comparing, contrasting a little bit today. There are some links to kind of the code demonstrations I'll be using. Yeah, this is me. This is where I'm from. Utah, United States. Just a short flight. And I made it. My luggage did not make it. I made it to Spain, so I'm happy to be here, excited to speak to you today. I'm an engineer with Pivotal. I'm not going to go into how I started at Pivotal, but it's an interesting story. If you want to hear it, ask me afterwards, and I'll tell you the story of how I came to work at Pivotal on Spring Cloud. I work with Dave Sire and a number of other folks that are just fabulous engineers on Spring. This is some of the other things we do at Pivotal. I love my capital D there. A little bit on the Spring Cloud roadmap. We just released Brixton a few days ago, not too long ago. So that's our second release. Our first release was called Angel. To kind of go along with some of the roadmap stuff that Phil and Jürgen talked about earlier this morning, we will have a Camden release. So our release trains are named. A Camden release will follow sometime after Spring Boot 1.4. And then we'll have another release that will follow Spring 5 and Boot 2 sometime next year. Again, Java 8 and all that niceness will come along with it. And we'll have a number of service releases in between. So, Microservices, anyone heard of? Yeah. I like this slide. I've seen it in a number of places, and I made my own just because I couldn't find a good picture of one. But when you start to move to this architecture, this cloud-native architecture with microservices, there's all sorts of stuff that comes along with it. How many were in Josh's presentation this morning? Oh, a fair number of you. Good. So he started to show you some of these patterns and these things that are used to overcome these issues and problems that need to be solved when you're using microservices. And so I get asked all the time. In fact, yesterday at the speaker's dinner, given a discovery system, right? The ones I'm going to talk about today, Eureka and Consul and Zookeeper, which one do you recommend? Like, tell me which one is the best one for me to use. And my answer is, well, it depends. and that's kind of the purpose of this talk, is to tell you the differences and show you some of the differences between these systems and why you might pick one over another. It would be the same thing, like, which database should I use? Should I use MySQL? Should I use Cassandra? Should I use Couchbase? Well, the answer is it depends. It depends on what your system requirements are and what the needs of your application are. So we'll get to talk about some of these things as we go on today. So service registration is a pretty simple pattern. It's been around for a long time in various forms, right? Josh talked about DNS, right? That's one form of it. But in essence, there's this registry, and when a service comes up, it says, hey, here I am. Here's my host, and here's my port, right? That's the simplest form. It's just a map of service to host and port. They can get more complicated than that, but that's the simplest form. And another service comes up, another instance of each of these services, right? You could have n number of these. And then when service B wants to talk to service A, it says, hey, registry, I don't know where A is. Can you tell me? And it will tell him. And then he can make his direct call to service A. I think what's changed recently with this cloud-native architecture is that the registry is loosely coupled, right? In the SOAP world, it was very structured, or with an enterprise service bus, it's very structured and controlled how you interact with the other services. And with a simple service registry, it just gives you a host and port, and the client has to know how to communicate with this other thing. So in Spring Cloud, we have a number of ways to interact with discovery services, a discovery server. So this is like Phil said, we love annotations. We love them. So this is the annotation that you get to enable your service to register with a discovery service at Enable Discovery Client. Once you do that, we will inject a discovery client for you. So this guy right here. And it has a very, very simple API that says, give me an instance of this service. Service instance basically has a host and a port in it, right? It's very, very simple. So that's one way you can interact with it. We also will instrument or augment a REST template so that instead of supplying a host and port in your URL, you just provide a name, and it will resolve that name for you. And then I think Josh mentioned this, he didn't get to show it, and I don't know if I'll have time either, is Feign. Feign is a declarative REST client, so where REST template is you walk through the programmatic steps to interact with a client. Feign, you declare annotations on an interface, and it lets you do a client that way. And we instrument that with Discovery as well. So there are a number of ways you can interact with Discovery using Spring Cloud. So configuration, Josh showed you a little bit about config server. And again, it's a very, very simple concept. How many have heard of the 12-factor app? Right? If you haven't, if you've never been to 12factor.net, it's a great read. Basically, this came from Heroku, and they said, we've found as we've built out our platform that these are some of the things that we adhere to. One of them is configuration. And they say you shouldn't bundle your configuration with your application. It should be external to your application. And in fact, they go as far as to say that configuration should be supplied to your application using environment variables. And I think we stick to that concept, but our Spring has a very concrete environment, a concrete abstraction. Isn't that funny? They have a concrete idea of an environment in Spring. And so we plug into that environment abstraction with distributed configuration. Again, service comes up, it just only has to know how to contact the config server, and then it pulls down its configuration. And any service that comes online can do that. So to do that, we have introduced, how many are familiar with the life cycle of Spring's application context? A little bit? So it has a life cycle where it starts, and there are certain application events that get that are emitted during the life cycle. And so to plug in configuration into that context, we created a new concept called a Bootstrap application context. And its job is specifically to go out and get configuration from this remote source, and then it takes those values, creates a property source, like Josh showed you, and I'll show you a little bit here as well, and injects that into the application context as though it were the normal application context. So Bootstrap happens, and then the normal application context proceeds. So it's interesting. It's kind of important to know this because it introduces this other layer into your application where you can do these things that prepare your application context before it actually starts. Okay? So there are a number of ways that we can interact with Spring's environment. Configuration properties. This is a Spring Boot concept, and I'll show you a little bit. Basically, you can annotate a plain old Java object, and you get type-safe configuration. It's a standard Spring Boot thing. At value, I believe Josh showed you that, right? Spring core annotation, where you can plug in a Spring expression and get a value out. Or there's the actual environment interface that you can get you can just inject into your application. My recommendation is to stick with configuration properties for most of those things, and I'll tell you why in a little bit. But not only do you get the type safety, there's validation that comes with like Hibernate Validator and a few other things that are nice about configuration properties. So the first configuration system we're going to talk about today is Config Server. This is a greenfield application. When we first started Spring Cloud, we wanted to have this external configuration system, and Netflix, we picked some of the Netflix stack to start with just because of its maturity. Well, they haven't open sourced their configuration server, so we had to build our own. It's a simple, really, really simple HTTP API. When we built it, we decided that having it backed by a version control system would give us some properties that we would otherwise have to build on our own. Our initial implementation is Git. We had a community submission for Subversion. I mean, anything that has a Java interface, I suspect you could wire in here, but hopefully we don't see a CVS or implementation anytime soon. So the config server is stateless. You can spin up as many as you want, and every request that comes down, it pulls down the configuration from the version control system. We introduce refresh scope, which Josh showed you a little bit about. I'll show you some more about how that works. We also store, in Brixton, we have the ability to serve plain text files. So people have wanted a place to consolidate other configuration besides that gets plugged into the Spring environment. So we've had someone, for example, wire up internationalization with the internationalized files coming from the config server, since Spring resources can be referenced via URL. So the other thing that's nice about the way we implemented this is that we use normal Spring Boot configuration files. Properties file, YAML file, the same thing, except you name the file based on the name that you give your microservice, like Josh showed you, springapplication.name. We have a auto-configured client, right? Put a starter on your class path, point it at the right config server, and it just kind of happens automatically. It can be refreshed via what we call the Spring Cloud bus, which is, I call it distributed actuator, so you could send a message on RabbitMQ and say, hey, everyone refresh your configuration. In Brixton, we added support for webhooks. So one of the requests we get quite often is, well, when my configuration changes, I want my apps to refresh. Well, it's Git, right? There's no online, we don't want to sit and pull Git. And so these services that support webhooks, we added support for that, where they can come back in and poke GitHub, can poke the config server, and then send a message out to get that refreshed. And there's commercial support for config server in Pivotal Cloud Foundry. So those are some of the attributes of config server. All right, let's see if I can fire up a demo. I'll try and show some different things than Josh did, hopefully. We'll see how it works. Let's see. So some of these coding demos are pretty underwhelming, right? Like, that was the code that I had to write to start config server, right? Is I had to add enable config server. Let's see, and for the server, similar to what Josh did, I give it a port, pointed at the URI for my config server, and give it a name. Pretty simple. Let me run config server. So show you a similar view to what Josh showed you. So if I have an application named foo, and it's just using the default profile, it will give a couple of property sources here. One, application.yaml or properties is common to all applications. And then foo.properties, since I was asking for the foo application, it brought me back that for foo that has a couple of messages here. Again, config server, really simple. I come back and run the client. So if I show you the client application, actually I want to show you the POM. So the config client, the important thing here is, where is he? Right here. So you add the Spring Cloud Starter config, start him up, and as long as he's pointed at the right config server, it will just work. So if I do this, I get my application on 8080. If I look at the environment, you'll see that I have two things plugged into the environment here from the config service. Application.yaml, and these are in the right order, right? So the upper one is more specific, so if there were anything in the common one, it could be overridden. Now let's see. I actually want to do something else here. I'm going to risk the demo gods. Run from, I was pointing at the local one, but I want to show you the webhooks. So if I start ngrok, and anyone heard of ngrok before? It's a pretty neat little application that creates a proxy out to the internet that will point back to my local machine for me. So what I'm going to do is go to GitHub. Come into the settings here. Go to my webhooks. I can see I've done this before. Plug in my local ngrok URL. If you see that, excuse me. Right, so this went out through the internet and back to my local desktop and served the same version of that configuration. So if I update that webhook, okay, let me make sure my bus is running. Okay, so now, show you my config client here, config server, and I have a, on my client, I've got just a little, did I start that back up? Yeah, so you see the last time I did this, I was in France, so let's see if I can fix that. So if I come to foo.properties, edit this guy, hello, spring, oh, and I'll change this. It's already close, right? So if I change this, come back to IntelliJ, you'll see, nice, that I received some logs here that were refreshing. I went and refetched from config server, and then I got a couple of keys that changed. So now if I come back to my application, you can see that foo.properties now lists hello spring IO and foo Barcelona. Also, you'll notice that this message is now updated. So, and I can show you this little bit here. So where Josh had he had an @value, right, in his class and a refresh scope. Well, configuration properties are automatically refreshable. So instead of having the @value, I have this configuration properties class, config client /.message, right, which is right here, right? And so I don't have to do anything special. It just automatically gets refreshed. If I'm always referencing this and don't set it as a variable, it will just get refreshed when that happens. So what happened was GitHub posted to my local config server put a message out on RabbitMQ. My client received the message on RabbitMQ and performed the refresh from the config server. Is how it all happened. So the demo gods were pleased. And it worked. So that's config server and config client. Oh, another thing I think is interesting with config server. Well, what if I have a Node.js application that I want to get its configuration from config server? I don't have a Java client. I mean, you could parse this, right? It's JSON, but it's specifically formatted for the Spring environment to be easy to integrate it with the Spring environment. Well, if you have a Node.js app that you want to serve up, we will format the environment for you, compress it all into one value, and hand that back to you as a JSON file. Or maybe it's a Rails app that you have. Well, we'll do it in YAML too, right? So we have these other options to get content out of the config repository. Let's see. there is a Bootstrap. So you can also, and I talked about plain text files, let's say default. Say my app needed this particular XML file, and it will serve it up just fine. But it's in the same repository that your configuration's in. Okay? So that's config server. A little more in depth. So, moving on to configuration systems, Netflix from Eureka. Excuse me, Eureka from Netflix. That's better. They built this because at the time there wasn't anything that really served their needs. They deployed into Amazon. They couldn't use an elastic load balancer at the time because at the time the elastic load balancers only sat at the edge, and they needed an internal solution. So they built Eureka Server. So they built it to be highly available. Eureka Server will try at all costs to give you data. And it will go through many hoops, it will jump over hurdles, it will cry, but it will still try and serve you data. Even if that data is old, it can get into this mode, this panic mode, where it stops receiving heartbeats. And once it reaches a threshold of clients that aren't talking to it, what it thinks should be talking to it, it says, okay, the outside world is having trouble. I'm going to stop dropping, because after a while, if it doesn't receive a heartbeat for a particular service, that service is gone. I shouldn't serve it up to someone else. But it will get into a mode where I'm panicking. I'm not going to drop those because I want to serve the stale data because I think the network's having a problem or the clients are having trouble connecting to me. So in the CAP theorem, right, this skews towards the available side. It's been around forever at Netflix, right? People ask, why did you pick this one? Well, they have literally thousands of clients connect to this daily to register and to get discovery information from. And they've been using it for years. Ribbon is the client-side load balancer. So you have like Apache or Nginx or in the hardware world an F5, right? That's a proxy load balancer that sits in front of a network. Ribbon is a client-side library, and it does load balancing at the client level. And there's tight integration between Eureka and Ribbon. Again, this is the one that we chose to support commercially on Cloud Foundry first because of some of these pros. Well, not everything's rosy with Eureka. I mean, we're all here at a spring conference, so this isn't a con to us, right? But many companies are polyglot, even Netflix, right? Their front-end systems are now written in Node.js, right? So this is a problem, even for them. Now that we have a client for Eureka, it is not a thin client. It can be a nasty piece of work sometimes, but it's a thick client. It has lots of logic that goes on in the client that if you had to replicate, you would be studying a fair amount of Java code to try and figure out exactly what it does in all the different cases. So if you want to do polyglot, you have to stand up a sidecar. We have a sidecar that you can run, but it's not ideal all the time. And initially it was built for AWS. So there's code in, I've looked through Eureka code I don't know how many times, and there's lots of places in there. If it's AWS, do this. Otherwise, do this, right? So a lot of the things are built for Amazon initially. But we've helped them, and others have helped them work through some of those challenges. And especially when you're doing demos, there are thresholds in both Ribbon and Eureka that it may take up to 90 seconds for another client to see the service that was just registered. Now, in Netflix eyes, those are the defaults. Those are okay, especially when you're talking hundreds or thousands of services. But when you start and there's one or two, 90 seconds for the first one can be a little long, and so you can tweak those values. So those are some of the issues with Eureka. Any questions? If anyone has a question, go ahead and shout it out. I hate to just sit up here and talk if someone wants to know something. So the next system we're going to talk about is Consul by HashiCorp. Anyone heard of Consul before? Fair number. Okay, those of you who haven't heard of Consul, you heard of Vagrant. A few more. Okay, same guys that wrote Vagrant wrote Consul. And Consul is an interesting system. It does both configuration and service discovery. They're both top-level concerns in Consul. It's polyglot by default. Its interface is an HTTP API. Actually, Consul for service discovery also has a DNS interface. So if you have a legacy application that the only way it knows how to talk is just to via a host and port that's served up via DNS, you can plug Consul into your existing DNS system and it would be able to route for those legacy systems that use DNS. There we go. I just talked about that. Another thing that is built into Consul is security. So they have a fairly flexible ACL system that allows you to partition and have permissions on what applications can only see their configuration. They can't see another application's configuration, for example. And also with service discovery. I don't think it might be there. I know it was planned, but being able to see what services are registered. There are some companies that have requirements on, hey, only certain applications should be able to see this particular service that is up, not every application. So they have a nice support of ACLs. They also support health checks. With Eureka, the way that Eureka knows that a server's up is that it consistently sends a heartbeat message every 30 seconds back. Well, with Consul, you can define absolutely anything that will tell Consul whether your app is up or not. So they have an HTTP check that says, as long as you can reach this URL, I'm good. But then anything that you can do on a shell will work here. So depending on your application's needs, you might need more than that, and it's flexible enough to handle that. It has I didn't mention this on Eureka. Eureka supports multi-data centers, but Consul also supports it. Data centers are a first-class concept in Consul. Consul is integrated with Vault. Vault is a new product from HashiCorp that is a key and secret management system, and I'll show you a little bit about that here in a minute. So it doesn't support files like config server, but it can support keys that look like files, and it supports both YAML and properties. So the contents of your keys look similar to the files that you would put in Git. Underneath, it uses a gossip system to communicate. So the way Consul is set up, you have a cluster of servers, 3 or more, right? 5 or more is probably better. And then you have agents running on each machine that connect to those servers. And to communicate and to announce the different nodes in the system, they have this nice peer-to-peer gossip system. So where Eureka lived in the available side of the CAP theorem, Consul tends to be on the consistent side. So it aims to be more consistent, but it also tries to be highly available. And it comes with a nice little UI that I'll show you here in a minute. Some of the cons of consul: it's young, right? This is new. It's not as well known as Eureka and maybe some of the others like Zookeeper that I'll talk about. The preferred way to do this, as I was talking about, is to run an agent on every node. So you have a little sidecar. There's only one binary for consul, and it works in either mode, and it's super small. It's written in Go, so it's not a huge overhead, but you do have to set that up on every host. So let's show you a little bit about consul here. All right, let me stop my old apps. Okay. So I already have running consul. So I started consul earlier. And then in this terminal I have Vault. So Vault is a separate system, but it can have multiple backends. One of them happens to be consul, and I decided to use that here because if you're using consul already, Vault plugs into that fairly easily. So if I come to my sample app, again, the application itself isn't that interesting. You see I have enabled DiscoveryClient, so this is going to register with consul. It says, hey, I'm a service, here I am. And we just have a little REST controller that grabs a application secret and a shared secret from the environment. And you'll see that I decided to use the environment interface from Spring in this particular case. So the POM, I can show you what I used here. Imported the starter, the Spring Cloud starter console config, and then the discovery starter, and also my Vault config artifact it's not released, it's not an official project yet, but I wanted to show the Vault integration. So that's the POM. If I get this guy started, don't mind the stack trace that you saw fly by. It's not the stack trace you were looking for. So this guy was on 9990. Okay, so that's not, again, nothing fancy to look at. But now if we come to environment, if you remember, we had configuration server was adding to our Spring environment. Now if we go look at the same environment, you'll see that we have a number of new configuration properties. We have a number from Vault, and some empty ones from console, as I don't have any configuration in console. But the app secret and the shared secret that I showed you here have been plugged into the via Vault and the Vault configuration properties. And if I show you the console UI here, so here, this is the service section. Make it a little bigger. And you can see that my app has registered, and it has 2 health checks. The surf is that gossip system that I was talking about, so the local agent is up. That's what that means. And then the check, right? So it actually did, we automatically configure the Spring Boot health actuator endpoint to be the console HTTP check, makes sense. We already have it, so let's use it. So that's what was done there. So if I start up another node, so this is something we haven't seen. Actually, that it's going to be a different service, so never mind. So this is another service that has a different ACL token than the first one. If I show you that, its environment, it got its information from a different key in Vault. Well, so now all I'm doing to pick which key is giving my Spring application name, right? So if I show you the YAML for this, right, I'm just saying my Spring application name is this guy. Well, couldn't I just change it to A and read A's configuration? Well, let's see what happens when I do that. So I have another YAML that says, okay, I'm going to say I'm A, but I'm using, this is where I define the token for Vault. I'm using the same token because I don't know the other token. I know it, but it's just one. But I'm using my token and the other app's name. And you'll see, now I actually want to show you the error here. So I got a 403 forbidden when trying to read properties from application A's configuration. So if I come to port 9992 now, show you this environment, you'll see that I couldn't read the environment from the other app because my ACLs wouldn't let me. That's how I've configured the system. So that's consul and Vault. If security is important to your application, that things are partitioned like this, then consul and Vault makes an excellent choice. So there's not a whole lot of security built into Eureka. In fact, in our commercial version, that's one of the value adds. We add some OAuth security to Eureka, but the open source version of Eureka, the only security it has is checking client certificates. So there's very little security built in there. Talk a little bit about Zookeeper as well. Anyone familiar with Zookeeper? A few of you, right? This is a coordination system. I can't get a clear definition of what a Zookeeper is, but it's a Swiss Army knife of things to help you in a distributed system. And one of the things it does is you can put data in a hierarchical key, and it is aggressively consistent, right? In fact, anyway, I'll talk about that in a second. It started life in the Hadoop ecosystem to coordinate the Hadoop clusters. It's been around for a long time, right? 2007-ish. Lots of companies already have it as part of their stack. So if you already have it, this may be a useful thing for you because you don't have to introduce something new to your application stack, right? If you've got Zookeeper, you can use it for discovery. So one of the nice things about it is you can register things with ephemeral nodes, right? And as soon as that connection's gone away, those nodes disappear, right? You could build a discovery system that way, right? Because each node will register and create an ephemeral node that part of its data is its host and port. And in fact, that's what Curator does in one of its recipes. Curator started life as a Netflix project, by the way, which is interesting. There are scale issues that have been reported. So this section here, I have no personal actually experience with these cons, right? I've never run Zookeeper at scale in production. So these are some of the things I've read about. And if you know better than I do, I'd love to know. It can be difficult to operate and might need a management process because the Zookeeper cluster is fairly static, and a management process like Exhibitor will allow the cluster to be updated at runtime. And again, those persistent connections, right? Once you get to so many persistent connections, you can't have unlimited persistent connections, so that could be a problem too. And we have support in Spring Cloud for Zookeeper, both as configuration and discovery, very similar to Eureka and Config Server and Consul, like I just showed you. So, some honorable mentions. People ask me all the time, do I really need that? And it's like, well, maybe not, right? Nginx or HA proxy may be good enough for your system. Josh actually submitted this. What if your platform already knows about all of your containers or your virtual machines? Couldn't it just tell you? Well, yes. So in Cloud Foundry, you could run as a read-only discovery system, right? It doesn't do any registration, but it picks up the registry from the underlying platform. I said, well, I wonder what it would look like to write something with etcd, right? And it didn't take me very long. And so pretty easy to create a new system. So if there's something new that comes up, it wouldn't be hard to integrate it into Spring Cloud, and your applications wouldn't have to change how they register, how they get their configuration, even though the source changes. Airbnb has some interesting code if you want to read about it. Really interesting video if you want to watch is about Hoover's Hyperbahn. It's unlike anything I've seen before, so it's really, really interesting if you want to go read about that. Okay, I'm speaking again. I'm doing a workshop, so if you liked Josh's talk earlier and want to try it yourself, bring your laptop to room 2 in a few hours, and I'll try and walk you through it. Again, there's the URL for these demos that I had. You can run them all yourselves. And any questions before I'm done? Anybody? Bueller? If not, you can come grab me afterwards. Thank you very much. Appreciate your time.